Our presenter today is Nicholas Reck, Technical Director for Pavements with Tensar International Corporation. Based in Atlanta, Georgia, Nicholas is a registered professional civil engineer with more than 20 years of worldwide experience in asphalt, interlayers, and pavements. At Tensar, he is responsible for pavement design assistance and worldwide research in forensics, internal and external training, making him suitably qualified to lead this event. Take it away, Nicholas.
Thank you, Brian, and good day to everyone, wherever you may be. And I look forward to presenting this topic to you on something that is a problem that most engineers are experiencing with specifying overlays for pavement structures. And it's quite interesting. The other day I was looking at an Xbox game, and I noticed that the artists are now including cracks in pavements as well, to that detail. So if you also watch the cartoon movie Cars recently, you'll also see that the Route 66 has a nice generous quantity of cracks. So they also have reflective crack problems in cartoon movies. So with that said, so let's give you an indication of what we're going to discuss today. So the table of contents includes a brief introduction, and then we'll follow that up with which interlayer product types Tensar currently offers in the context of other products. Then we'll focus on crack mechanisms, because we need to understand how these products work relative to the different crack types that are out there, because there are many. And we'll look at some testing for these interlayers, because we also have to understand with the multitude of products out there, which ones work better for which crack type. Then finally, the crack distress identification guidelines that are currently out there, just give you some tips in terms of what you're using and how that relates to reflective cracking. And then finally, we'll give you the Tensar interlayer selection guide and some design considerations for you to include when you look at your projects. So with that said, let's have a look at some of these products out there to give you an indication of what to look for and why they can be of benefit to you. So the first product, and it's probably one of the more well-known products, is a paving grid. And those of you that are aware that steel mesh is used in concrete, we know that concrete to be tensile weak and very good in compression. And asphalt has a very similar tendency. Yes, it's thermo, viscoelastic, plastic, but ultimately it's very good in compression, and it has a weakness with respect to tension. So the two concepts work very well together. You're putting in a material with a modulus advantage over the surrounding materials, which is ultimately to give you that tensile support when it's required. Now, one thing you can see about a paving grid, the definition of it, you can see some apertures there in the product, so you can ultimately see through it. And why do you do that? The same type of principle applies in concrete. You want the surrounding materials to envelop it, so that when movement takes place, those very small movements that happen at very high speeds, very short durations, you want to be able to transfer the stresses onto the reinforcement quickly and efficiently. So that's why you want an open grid structure. Now, the products typically get installed with adhesives so that they stick to the supporting surface, so you get an intimate contact. And when the cracks move beneath it, the crack strain gets transferred onto the reinforcing element efficiently and quickly. There's nothing in the way. Some of these products, composite grids, for example, have used paving fabrics or other fabrics underneath the grid to install these products. But unfortunately, as you can imagine, the transfer of stress onto the reinforcing element gets compromised, and it's not as efficient. So the structure of a product is important, and paving grids offer you an opportunity to put something in direct contact with your environment. The other thing that's also important, you'll see that we're referring to glass. Well, glass has the benefit that it has a modulus advantage over asphalt at a range of different temperature conditions, because asphalt will experience whatever the environment hands to it. So at low temperatures, you have a very high modulus, and at warm temperatures, it can soften appreciably. And your reinforcement must be able to provide a benefit. And given that we're referring to cracking, you know, the fracture characteristics of asphalt are at risk at lower temperatures and also when the material is aged. So looking at this graph or this chart here, you can see that you want a modulus advantage in the conditions where the material is more vulnerable. And another case in point is when you're looking at testing of these materials, is it valuable to evaluate asphalt at room temperature when typically the risks are associated at low temperatures or when the material is brittle? Now, to move on, we spoke about a product that has great bonding characteristics and integrates itself well. And we've seen we want a material that has a stiffness modulus advantage over the surrounding materials. Well, paving fabrics, which we're not covering in this specific presentation, have been around for quite a while. They basically started the interlayer trend. And some of their benefits is that they also offer a moisture barrier. So typically with your paving grid, you do reduce the incidence of moisture movement, but you do not prevent it. And so there are other products out there. And a paving mat is probably the newest interlayer product out there. It's about 10 years old. Probably over 10 million square meters of material have been installed to date. And it's really a fast-growing interlayer. And why is that? Because we have increased the use of wrap in our day-to-day design. And when you include a non-woven paving fabric in your structure, the incidence of fabric in your wrap mix prevents you from reusing it as is. So it typically has to be screened, and it's a very expensive exercise, and most contractors do not wish to do that. So it's important for you to keep in mind that when you are specifying paving fabric, you may have an issue with respect to the wrap not being able to be used in the future. There are some facilities in the United States that can screen the material, but very few. I think I can think of 2 at present. So that is a consideration. So the paving mat really came about in that they were looking for a product that could give you the continuous moisture barrier benefits, but at the same time also perform more like a grid. So they came up with a material that can do both. Looks like a fabric and performs like a grid. And it's recyclable. So that was a great transition that has occurred, and you now have a paving mat available for your use. Another product that is also available is in conditions where you want to, or you have distress in very localized areas. Remember, a lot of these materials require a tack coat for installation. So you have to come down with your distributor and spray tack on the road surface before you install your product. And that's quite a lengthy exercise. So it lends itself to larger application areas. Where you have just a localized crack, you would like to just come in and, what I like to term it, a Band-Aid. You just want to install some material over an isolated crack here or there. Then you have this peel and stick product. So it basically has its own tack coat attached to it. So you can get the same benefits of your full width application, but you can install it in very localized areas. So it makes it a very cost-effective technique or use of interlayers. And remember, I think this is a benefit of interlayers, which is quite foreign to most pavement engineers, in that most of our strategies we adopt apart from patching, of course, but in most rehabilitation projects or maintenance projects, we look to cover large areas of the road surface because that's traditional. And doing it, putting it on your sections, you'd prefer to do that. The nice thing about an interlayer, you can stop and start the use of these materials without having to make it continuous. And we know that pavements deteriorate in very isolated areas. So you have severe areas and less severe, but you typically apply a standard approach, a standard overlay thickness. And you can use an interlayer within that individual design section wherever you wish to without having to change the profile thickness, which generally creates problems. So in this particular case, it lends you that convenience. Now, a question that's often asked with respect to the use of interlayers on milled surfaces or plain surfaces is, can you put these products on a grind? Now, very simply speaking, yes, you can install anything, anywhere, and probably do it without much risk. And but we know grinds of 3 millimeters exist. Sorry about the metric reference, but 3 millimeters, and some of them go up to 1 inch or 25 millimeters. So you can have this huge variation in grind profile texture. And the important thing is that, yes, again, go ahead and mill to your heart's content and put the products down, but recognize that it does influence your performance. So I'm going to show you this very busy graph. And on the x-axis, you can see different grinds. You could consider a level up if you didn't want to put it on a milled surface. And then I'm referencing 3 different grind textures, 6 millimeters up to 19 millimeters. Now, I'm not going to go into this in depth because it's quite expensive, but if you just take the bending type of distress, then what we're saying here is at 6 millimeters, you have, roughly speaking, a 10% loss of strength if the material is installed directly on that grind. So what we do recognize is that there is some loss of serviceability associated with putting it directly on a ground surface, and that stands to reason because it's a stiff product, and you are going to get some installation damage. And remember that we account or allow for almost 30% damage associated with installation anyway, so you could eat that up pretty comfortably with respect to using it on a micro mill of 6 millimeters. But notice when you're going up to 19 millimeters, especially if you've got really severe distress types, let's talk about thermal cracking or, I've got here thermal or shear cracking, the impact is more severe, so one has to take that into consideration. So yes, you can put it on any mold surface or any textured surface, but remember, you'd have to consider a stronger product than you would normally use if your textures are much greater. So anything I'd say for most of these products up to 3/8 inch up to 1/2 inch, you're probably pretty comfortable. Anything greater than that, stay away from your more severe distress types. So textured surface is a consideration. Another question that's often asked, with all the Tensar products, our minimum thickness in all cases is 1.5 inches. I always recommend speak with other manufacturers. For example, 2 inches is recommended on top of paving fabrics, for example, and some other manufacturers may recommend that as well. Sometimes there are thickness constraints put on at intersections, for example, where there's a concern about the mix walking or shearing or flowing, however you want to reference it. And my suggestion is before you start playing with thickness, let's look at the project holistically. I wouldn't suggest that just increasing the thickness is going to solve your issue if your mix is walking on top of the interlayer. So other than that, typically you can get away with these minimum thicknesses in all other cases. Then you'll say to me, but hold on a moment, I heard the other day that you can use an interlayer underneath a chip seal. And I have 3 cases, and hopefully you can see this. I apologize for the quality of the slide. The top one refers to a single seal. Then you have a double seal underneath that, and a cape seal beneath that. And I'm not really concerned about the specific aggregate sizes associated with each of these, other than to say that a double chip seal comprises 2 different size materials used in conjunction with one another. So it could be a 19 millimeter with a 6 millimeter chip on top. But irrespective, those 2 are more structurally stable. And it goes back to that walking concept, and I'm sorry if that's an unusual concept that I'm referring to, but walking is typically the movement of particulate under traffic, so under braking, turning, acceleration. And a single chip, unfortunately, the aggregate is more likely to walk because it's not confined, whereas in a double chip you offer that stability. And that's why I say you could consider the use of interlayers underneath a double seal or a cape seal. And paving fabrics have traditionally been used for that. We would recommend a paving mat as a good alternative to that. And ultimately it's a pretty good insurance, increasing your binder content as a reservoir for your application, and also to protect your seal from cracks from coming through. But ultimately, yep, so thicknesses do vary as it relates specifically to chip seal applications. Now, where and why, I've got a range of application types here, so you can hopefully see that that's an airplane. And for the tennis players in you, you can probably relate to that one. You see some ports, parking areas, residential, anywhere where you typically use asphalt as a surfacing is where you could consider, addressing reflective cracking. And that's the trigger. In some cases, there is the use of the reinforcement. If used in a specific location in the pavement structure, you can actually get some reinforcing benefits, but that needs to be designed, and you'll see some boundary conditions, and we'll discuss it later on. Then I've also got a couple of pictures of some different distress types, and what we recognize is, and I had a discussion this morning, we typically lump all these things under reflective cracking, but the reality is there are multiple crack types, as you'll see shortly. But in terms of this, ultimately, whether you use overlays or double chip seals, cape seals, or where you're doing rehabilitation, you have to consider you're trying to protect the flexible pavement from moisture, or where you're trying to address reflective cracking. Okay, so this topic is also an important one for you, again, because of the RAP consideration, and important for you to get actual data from the manufacturers, because all of them do state their products are millable, which is totally correct. Anything can be milled up. But again, you would like your product to look like this, so that it includes particulate that is not going to compromise the reconstitution of the material when included with new asphalt. So please make sure that you have reports provided to you to support this. So for example, this is a study, or an excerpt from a study done at NCAT to confirm that the RAP, including milled particulate from an interlayer, did not compromise the performance. Okay, good. So we're moving on nicely. And Nicole, would you kindly shoot out the next survey, please? Thank you. So we're going to touch on that, and ultimately now this is the understanding of crack mechanisms. And you'll see it's, you're going to say to me, well, why do we need to know this? And I think it's important to understand how these things work, because it enables you to select an interlayer to best suit its performance and to match a specific product to your project. So I like to teach you how to fish as opposed to just teaching you to eat the fish, if that makes any sense. And so I apologize for the theory, but it's always good to have this background. This application is very close to engineering judgment, and I like to think of this as building your engineering judgment base for you to approach this application with with less risk and greater success. So we have a great audience today online, so if you can give us a little moment to put together the results. So what's interesting here is, let's see, we've got, all right. Okay, so this is a little bit of a technical question. So which will have a higher measured tensile strain under a 120 kip dual wheel load? So it's a little bit of a trick question, but it's a flexible pavement, so we're trying to understand which of those is creating a higher strain level. So the answer, let's see, the user's fatigue cracking, 33%, and in actual fact, the answers that I was looking for is that reflective cracking is ultimately the one that's going to produce a higher level of strain, because in actual fact that's the case. It's your higher load causes a much higher deflection in your pavement structure, and when you have an existing crack, the crack will mobilize to the extent that you will have much higher strain levels associated with reflective cracking than fatigue cracking. So why is that important to you? because we need to know that when you're testing different materials, so rubber-modified asphalts or fiber-modified asphalts, which are typically also providing some form of fracture performance. Remember that fracture performance for fatigue is at a much lower level than fracture performance for reflective cracking. So that's an important consideration. So when you're evaluating data to use different materials, take that into consideration, because most of our testing that we do today on materials is associated with fatigue cracking. There's very few standardized tests for reflective cracking. But keep that in mind. Strain levels are significant order of magnitude difference. And the other thing is, remember I told you about low temperature and age. The low temperature performance is of greater significance because your fracture performance is more at risk. All right, good. Thank you, Nicole. So the first thing is, the use of interlayers to address reflective cracking, and I apologize for a typo there, but it's been used for over 30 years. So the concept of sticking something between layers and laminated layers in a pavement structure is not foreign. And the use of seals or chip seals or sand slurries prior to that were used probably for 20 years before that. So it's the fact that levels of performance were never achieved that they basically evolved into trying new things. And so, that's how glass evolved. They started with polypropylene grids, they moved to polyester grids, they moved to glass. And we're still playing with basalt type grids. We're looking at carbon fiber grids. We've played with steel grids. We've tried different things to see how they could integrate themselves. And I'd say that glass has proven to be probably the most strain compatible with asphalts across those wide range of conditions. Okay, so the first type of reflective cracking that would be of interest to you, and it relates to that first poll, the second poll question, is the one of bending. So that's typically where you have a crack sitting in a pavement, you stick an overlay on it, and nothing happens until a vehicle drives over it. Then your pavement structure flexes, and that deflection is basically associated with moving the crack. So that crack, that strain then develops at that point and wants to reflect up through your overlay. So this is this type of crack is a match made in heaven with your interlayers. It's an easy one for the interlayer to address, and typically the boundary conditions are not as rigorous as they are for other distress types. So that's a good thing. And so how do we evaluate that? Well, the 4-point beam test is a pretty good indicator of performance in this type of situation. And those of you familiar with the test know it's a cyclically loaded test, so you're not just applying continuous pressure. You're loading it as you would in the field with traffic. And typically the test is done unnotched, but in this particular case, to evaluate reflective cracking, we notch it. And because the performance of these composite systems is so good and could take a couple of days to run, we increase the strain levels. So you're typically doing strain levels that represent a thin residential street. So those sort of load levels under a standard heavily weighted truck axle load. And so we're putting it under a very aggressive torture test type condition, and we're looking at both crack growth or composite stiffness loss with and evaluating to what extent the interlayer can benefit that. So there are some studies that one was published at the TRB in January this year, and I thought there's something interesting to share with you. This is, and I apologize for the size of the graph, but it just gives you the general indication of the results. So we spoke about stiffness loss earlier, and the upper graph presents a trend and showing you how the stiffness deteriorates with time. And then once you've achieved a certain level of stiffness loss, that depicts what your level of serviceability is for that performance of that system. But the graphs below it, and I apologize there's so many there, but the interesting thing is here is what they did was they used digital imaging capturing technology to evaluate the beam as it is loaded. And those little white marks over there represent strain that constitutes or represents cracking or fracturing. Now, the beautiful thing about this, and remember this is under flexure, is you can see what the performance is at the interlayer and what the performance of the crack is going through it. Well, when you look at the specimen after the test is completed, you'd be amazed to see that there are no cracks. So you actually go there and you go, well, how is it possible we can see fracture during displacement, but you don't see fracture post the test? And there are a couple of reasons for that. Number one is the asphalt is relatively new. And number two is the test is done at room temperature. And so there are those considerations. But it does answer the question, you know, when we're doing pavement management system surveys, then are we able to see the stress in our pavements early enough? And this one gives you an indication that we're already getting the stress in our materials without actually physically being able to see it. And it brings about the question, do you use this non-visual criteria to determine performance, or do you wait for the visual distress to occur before you can actually start predicting how things are going to work? But it was definitely a challenge that we had to face, and was really an interesting one. So, good. The next type of crack is a shear crack, and this one is best represented by composite pavements. So this is where you have your joints moving vertically under traffic loads, where your dowel bars are typically located, and you get a relative movement of the slab. So we talk about load transfer if the two slabs are moving down completely in sync with one another. Then we talk about 100% load transfer because there's no relative movement. And typically when the pavement structure is new, you would hope that you experience that condition. And then with time, you know, I'm based down here in Louisiana at the moment, they have experience with 20 to 50-year-old slabs, and clearly you get loss of serviceability with respect to load transfer, and you can end up with structures with sitting at 30 to 50% load transfer, which is typically a failed condition, according to AASHTO, where I think everything up to 60% is probably in a relatively poor condition. So what's important here is, because this is such a severe distress type, is to understand what are the boundary conditions associated. So because it's such a severe distress type and we specifying load transfer, not a lot of people go out and measure it. Firstly, because you have to use a falling weight deflectometer to go and do it, or there is not a freely available technology to go out and do this. But let's say you didn't have that information available, then we look at some other indicators. One thing we've learned with experience, I think our first ever project with Glassgrid was on an 80-foot long slab. And it wasn't a real project, we just provided some materials for trials. And clearly the movement at that slab was so significant, because if you apply a very little load at one end of the slab, you get a high movement on the other. And so we've learned over time that typically slabs lengths of 6 meters or less under conventional conditions would be an indicator for us that, hey, this is something we can handle, that the need to go and get data is less important, however, doesn't get ruled out. So the next criteria we look at is the number of mid-slab fractures that you're experiencing. And we typically say that if your mid-slab fractures are, if the number of slabs of the total length are less than 30%, then we are still in a reasonable range of level of serviceability. But anything greater than those, we start recommending that some form of measurement starts taking place before you start spending money or investing in interlayer systems to assist you with this. So this ties in very nicely sort of with the criteria that is used by AASHTO, but we feel that these are good boundary conditions or assessment techniques for you to adopt. All right. The last severe one is thermal cracking. And why is thermal cracking so severe? Because with respect to our product, we put it in, and it's parallel to the relative movement that's taking place. So that is why the structure of the product now plays a key role in how you can transfer stress onto the reinforcing element. So paving grid that was mentioned right in the beginning is better suited to this type of application because your movement has to transfer the stress parallel to the reinforcing product. So an open structure product is very well suited to this type of application. The levels of serviceability or boundary conditions are just as prevalent. So we do look at the fact that what the climatic condition is where you're doing this. So we do recommend that you speak to the manufacturer and confirm the level of suitability in the specific area that you've placed the product. We've applied it in very, very aggressive cold regions where the level of movement was way in excess of what our product can handle. So please understand that that boundary condition does exist, and we do use empirical tools to help determine that. So I'm not going to tell you that there's one specific city where you have a problem, because your pavement geometry can also assist in determining how your thermal profile develops in that sort of thermal condition. So there are a couple of things that need to be considered, but we do use empirical tools to assist us in the evaluation. All right. So with that being said, so we've gone through those things. So how do we evaluate these? How do we know they work or don't work? Well, fortunately, the Texas Transportation Institute developed a criteria using the TTI overlay tester. They use this to evaluate the mixes post-construction to determine how they perform from a fracture perspective. That's related more to fatigue. And so what we decided is, well, we could use this technology. We've changed the way that the material is loaded. We use monotonic testing, and we also reduce the temperature at which the test is performed. Why do we do that? We do that so that we can actually reduce the repeatability in the test, because we want to improve its sensitivity. And we also believe that at lower temperatures, we get a better understanding of the performance of the mix when it's more likely to fracture. So with that being said, what the test does is it applies a load, if you look at the graph here, and eventually it reaches a peak displacement. The asphalt at that point does not necessarily fracture. If you go back to that those other test results that I showed you earlier, you may not necessarily see a crack at that point, but it's a point at which you've exceeded the strain capacity of that material. And then it shoots off and you lose significant tensile serviceability. So we basically, the nice thing about these tests is we can manufacture the specimen, a composite specimen, using a gyratory compactor. And so we also like the fact that we can produce a specimen with better repeatability. Where we typically, if you're manufacturing samples for interlayer testing, they're normally large specimen, and with a beam or slab, you can typically get plus or minus 4% air voids, which for reflective cracking is quite sad. And so ultimately, we really like the fact that we have a better quality control. Now you can also take specimens from the field and test those, but ultimately we love the concept of this test. Here's an example of the repeatability. So these are three samples. You always do 3 replicates. It's a really relatively inexpensive test, and here you can see outstanding repeatability. Those of you that have studied or looked at interlayer testing in the past will see that in actual fact, this blows research away. So I can refer you to the Nottingham study done in 2000 in the UK, and if you go and see, their results were pretty much all over the place, and they did beam testing. So this has given us a great sense of confidence going forward. So here's an example of 3 tests that were done. Remember, well, actually 9, but 3 average tests. The lowest curve there is relating displacement of the sample versus load, and you can see that the control specimen has a relatively, we don't want to call it poor performance, but a relatively low performance. And now if you use a stronger material, in this particular case it was a paving mat, a low-strength paving mat, and you can see what it's done is it's shifted the fracture point so it allows it to experience greater load and also greater displacement. So it's exactly the same asphalt mix, but you've improved its serviceability with respect to fracture. So that's very important. I think it allows you to consider these products in conditions that experience greater load or experiencing more cracking or experiencing distress from block cracking, etc. And then ultimately, as you go to the stronger product, there you can see even greater load capacity. So you could consider, where you have a much higher percentage of truck traffic, you could consider using a stronger product. What does this mean? This means that you can now start comparing other products, because of the excellent repeatability, you've got much greater sensitivity to evaluating different materials. Some other interesting things that have come out of it. We typically specify interlayers according to tensile strength. And yes, there is a correlation between tensile strength and performance, but only within a unique product group. So if I've got a paving grid, and I did a 50 versus 100 versus 200, then there's definitely a correlational trend within that product range. If I change the structure of the product, then 100 kilonewton is not equivalent to another 100 kilonewton because the structure is different. Now, looking at these results, and I apologize, there's so many, but I think, let's take a glass pave, that's paving mat product that I introduced to you right at the beginning. That's a 50 kilonewton product. It's got a reflective crack index, which represents the ability to provide load, higher load, and higher strain capacity. So that 6 index is ranked relative to the control. So the control would be, and remember, all the same mix was used for all these products. So the control is a factor of 1. What's interesting is next to the paving mat, we have 2 composite grids. That's with a glass grid attached to a fabric. And remember I said the fabric, you lose efficiency. Well, look at that. You lose 1/3 of the performance of the product simply by including a fabric to the grid. So those 2 composite grid specimen next to the glass pave on the left are perform, 1/3 less. And then if you take another product, and we won't mention the specific name, but it's a product supplied by Husker, but it's a polyester interlayer product. So it comes with a different polymer, but it's also assigned a 50 kilonewton strength. It is 2/3 less performance relative to the glass pave 50. So structure is very important with respect to this. What I'd like to see, and this is what we're working towards, is to come up with a specification that calls for a reflective crack index. Because then what your industry can do is supply products irrespective of the structure according to performance. So that it links better to performance than simply just product indexes. So I think that hopefully that illustrates that pretty nicely. All right, good. My voice is holding out, so that's a good thing. With respect to crack distress identification, because we mentioned we look at this stuff all day long, we'd like you to go out to the site and when you look at your project, identify what type of distresses. So we spoke about shear earlier on and things like drainage failures and things like that. It's good to understand the mechanisms that are associated with these applications because they can have an impact on the overall performance of the structure, not necessarily the interlayer. But we need to take that into consideration. So it's important to, for example, this little triangle represents a little bit of lateral shear at an intersection. We have to know that your mixers are walking around, because if they're walking around, you don't need to reinforce them. You have other problems. One needs to sort out the stability of the asphalt first prior to addressing reflective cracking, because you don't need reflective cracking when the mixers walk around. But I think it's important to keep this in mind, which is why we typically ask for a profile of the distress types that are being addressed in your specific area. Now we use the Federal Highways Distress Identification Manual or whatever local manual is used by an agency. So we work worldwide, and it's amazing. Apart from the fact that I've never understood the Russian language, the distress types are pretty much similar to those that we characterize here in the United States. What is important to recognize with respect to the difference between characterizing cracks is that we talk about degree and extent of cracks in pavement management systems. And you would think that the degree of the crack would give you an indication of severity. Well, the reality is it doesn't. It doesn't relate to reflective cracking. So just remember that a high degree severity crack with respect to a pavement management system does not mean that it's going to be a high severity reflective crack in a pavement application. In fact, a low severity reflective crack from a pavement management standpoint under heavy loading can actually be a very high intensity reflective crack. So that's not to confuse you. It's just to make sure that you don't use the pavement management system criteria to determine severity of of reflective cracking. All right, so let's look at interlayer selection and design aspects. And I think at this point, I'm going to ask Nicole to roll out the next survey, please, Nicole. And so we're going to have, we'll have some responses soon. But I think the important thing is you'll see that most manufacturers will actually give you some recommendations in terms of where their products can be used. The one thing I suggest you do is remember boundary conditions. You know, we engineers, everything has a boundary conditions. You know, we work with factors of safety and everything, even fatigue models. You know, transfer functions that we use in mechanistic empirical design have boundary conditions. So, you know, understand that reflective cracking has the same type of phenomenon and doesn't deviate from engineering principles in any way. So we encourage you to request those boundary conditions with any application that you refer the material or request information from your manufacturer or supplier. Okay. All right, so basically what we did was we requested that the users identify, let's have a quick look here, which of the following distresses are considered and should have boundary conditions. And yeah, so which of these have boundary conditions associated with them? And so we asked the audience to provide their responses, and let's have a quick look at that. So the first thing is, let's see, cracking, reflective cracking, lane widening reflective cracking. 11% suggested that. 5% said composite joint reflective cracking. Some said 5% said thermal cracking. And let's see, oh, great. All of the above, 67%. So I led you down that path, and most of you have replied all of them. And I agree fully with that. And if there's one thing you take away from this presentation, it is that all interlayer reflective crack applications do have boundary conditions. You need to find them if you don't have them presented to you. So make sure that you fully understand those when using these. Now remember, there are a range of possible solutions for reflective cracking. And some of them include, some people just use mill and fill. Some people consider modified asphalt mixtures or fiber modified asphalt mixtures. The reality is, remember, if you're using something for reflective cracking, please appreciate you need to see data associated with higher strain related testing as opposed to conventional fracture performance under conventional fatigue fracture. Those are two very different phenomena, so please keep that in consideration before trying those things. And then in terms of interlayer, again, that is for your higher strain levels, and it's better suited for that. All right, excellent. So, you know, I spoke about boundary conditions, and you could have said to me, hey, Nicholas, why didn't we just go straight to this where and why to use interlayers? Because ultimately I wouldn't have to be explained why bending and thermal and shear and wada. But ultimately the beautiful thing is we have a guideline here for you, and you're not intended to read this. What I want to show you is on your y-axis, on the left-hand side, we have a range of different loading applications with some traffic criteria. On the x-axis at the top, we have a wide range of distress types, whether you're looking for structural reinforcement or whether you're just looking for distress, how to address specific distress types, or a multitude of distress types. And then we recommend which of our products is best suited for that application. So it's a shortcut to not having to understand which distress type is better. And you'll see companies like Tensar, Mirify will have similar guidelines for their products. Husker, another very good company, would even adopt guidelines for the use of their materials. But ultimately, once you've selected your product, it's best to contact the company, and some of them, and Tensar does, would offer you the opportunity to use design, and we encourage that. Why? So we can do a calculation and make sure it's a cost-effective application for you. We do compare the analysis to what it would require to use conventional asphalt, and we do use public domain software to do the analysis, so we can actually supply you with the analysis tools and the research that was done to analyze that, and you can keep that for yourself. The nice thing is you can put it in your drawer, and you can come back, and every time the salesperson comes in, you can challenge them on the performance relative to what was predicted. But it makes sure that you're using the products cost effectively. Then the tools that we use two primary software tools. One is ArcDeso, which is a thermal crack evaluation tool, and the other one is the AllCrack software. Both of them were produced after 5 years of study, so comprehensive programs, and give you a very good indication of the empirical performance of these interlayer systems, again with and without asphalt. So that's pretty neat. Something else that we do, and this may look a little foreign to you, I'll try and present this quickly to you. The vertical axis here gives you the depth of the structure, and the red and yellow lines represents the tensile strain, measured tensile strain, when applying a load to the pavement structure. So you can see the red line starts on the right-hand side of the vertical axis, and that means the material is in compression. And as it moves and crosses over the y-axis in the center, it moves into a tensile state. So if you look at where the interlayer position is located, it means that the product is located deep enough down in the structure so that it can accommodate or perform in tension. Now, the product does not have to perform in tension when it's performing reflective crack function. However, if you wanted to also provide a reinforcing function, then it has to be in a zone in tension. The other consideration that you want to include the material deeper down is to ensure that it's deep enough so that if you come and mill over it, that you don't remove your reinforcing component in your pavement structure. So those are two fundamental concepts. Then the AllCrack, the input is basically just the geometry of your pavement structure and loading that you're using. So we use this for ports as well as residential streets. So it's a pretty simplified approach. We define the crack type and what the interlayer type. So we can evaluate any interlayer product on the market because the tool was developed including a wide range of interlayer products. The output is very straightforward. We get a reinforced result versus unreinforced, and again we can evaluate thicker versus thinner overlays. We ultimately provide you a report like this. It's done free of charge, and it gives you a basic indication of what criteria is necessary, what are the installation considerations to ensure that you receive or achieve good performance. So all of that is done for you. We include the photographs that you've sent us. We will evaluate the photographs and say, gee, nice car, or no, we focus on, well, that crack type doesn't look quite like the distress type that we've evaluated, so we need some additional information. But we do look at that and provide that to you. In some cases, we will, depending on what you're wanting the product to do, we will evaluate the stress-strain relationship to see where the product is in tension or in compression. So that's something we do. We will demonstrate or show you where the product is within the section. We typically want to make sure, and we will ask you what mix type you're using to ensure that the asphalts, we don't want to compromise the way that you design your asphalt layer thicknesses with respect to the asphalt mixes that you use. So your fundamental rules on aggregate size relative to thickness must still apply, and we don't want to compromise that. So we do address that and evaluate it and present that in the report for you. So again, these results are presented to you, and it's good for your reference and for your files. The thermal criteria, again, you don't need to send us the temperatures. We can identify the nearest city or town to your project. We'll collect data and evaluate the performance of thermal activity in that specific location. Then the photographs, like I mentioned to you before, we do like to see things like that. This top right-hand photograph, you can see there's a bit of an area where the asphalt has got a bit of it's stripped, or you've got a void. And typically we'll make a recommendation in terms of, hey, we don't want the product spanning something like that, so we will advise you on what techniques to adopt to ensure that you don't just simply apply the product and span a void. of that magnitude. So photographs are great. They're awesome tools. They cross barriers, language barriers, and I understand them. Doesn't matter if it's in Russian or Greek or anything. So please feel free to send me as many photographs as you want. I love them. And then, yeah, again, this report is again your best friend and a way to ensure that you keep us honest. Just to give you an indication, the soil crack analysis allowed us to evaluate the impact of installation damage. So some products have different coding systems, and it's sensitive enough for us to account for the evaluation between different coding systems on Interlayer products. So for me as an engineer, it definitely provides us the flexibility to evaluate the performance of these products.